Hi, good evening, everyone. So today we are going to go ahead and we are going to start talking about an important topic, which is quasi-concavity and quasi-convexity. Majorly speaking, whenever we talk about quasi-concavity and quasi-convexity, we want to go ahead and we want to deal with two kind of questions here. One, which is a one variable function, and two, which is a two variable function. Before we talk about one variable or two variable functions, we need to also talk about something which is called as a convex set. Convex set, you may be aware of it, and I will go ahead and I will just re-upload that video, which is especially on what convex sets are. But quickly to summarize what is a convex set, if we go ahead and if we right. So when we talk about convex set, what is a convex set? Whenever we take, suppose I talk about a circle is a set. Now, when I go ahead and when I draw a circle, then for a circle, what I need is, I need X, Y coordinates. I need XY coordinates, right? Which means that whenever I have to write the equation of a circle, it will be 2D equation, right? So for example, if I say Z, or you can also take it as R square, is equal to X minus A whole square plus Y minus B whole square. So you see, I need X coordinate and I need a Y coordinate to mention the center of a circle, right? And then there are three things which are fluctuating in this, right? One is the fluctuation of the radius. You can take different values of radius. And one is the fluctuation of point A and point B, which go ahead and define the center of the circle for you, right? So in this case, what we are going ahead and what we are saying is that we are talking about it being a function of two things. It being a function of X and Y, right? As against this, we can also go ahead and we can also talk about single variables. For example, we can talk about Y as a function of X, right? So that is also something that we can talk about, and that is also something where we can go ahead and we can say whether it is a convex set or not. I will talk about that also. But when we talk about these 2D diagrams, right? Then in these 2D diagrams, what we go ahead and what we say is, you take 2 points, any 2 points, you join it by a line segment. If this line segment, it lies within the set, then it is a convex set. You take any 2 points, join it with the line segment. If it is lying within the set, it is a convex set. Now, consider this. This is the diagram that I have. And I'm asking, is this a convex set? Right? Answer is no. If I take any 2 points, I join it with a line segment, some part of the line lies outside the set. Therefore, it is not convex set. Now, I will be using this in today's class to explain you about quasi-concavity convexity. So you just have to be aware about what this is all about what this set is all about, right? Now, let us talk at the same time about a one-dimensional figure also. I want to talk about 1D diagram also. Okay? So for example, what can happen in one-dimensional? How do I talk about convex set? Let's say that I go ahead and I tell you that, I have any function given to me. Like, for example, I tell you y is equal to x square, right? Now, in this case, whenever we have y is equal to x square, or whenever I have, say, y is equal to root x, right? Now, in this case, it's not two variables. You see here I was having two variables, x and y. It was being plotted as a 2D diagram. But that's not something I require here, right? In this case, what is happening is just y is just a function of a single variable x. Now, in such cases, if I have to check whether something is a convex set or not, and I will talk about it in detail, but just understand, if I have to talk about something being a convex set or not, what we can go ahead and do is we can look at the domain of x, right? What we can look at? We can look at the domain of x. Now, to give you examples of how we can talk about the domain of x, let me take some examples of the domain. So, for example, I go ahead and I give you a domain, and I just go ahead and I call this domain as, say, from 8 to 20. This is where my x belongs to. Now, what we can do? Well, it's very simple. If I will have 8 here and I will have 20 here, this will be my number line. This is the part of the domain, including 8, including 20. What is the definition of the convex set? The definition of convex set is you take any 2 points, join it with a line segment. The line should go ahead and lie completely within the set. So I take any 2 points within the set, I join it with a line segment. It lies completely within the set. So this is actually a convex set. In fact, if I go ahead and even if I go ahead and I take this from 8 to 20, 8 and 20 are not included, no problem. But I take any 2 point within this set. I join it with a line segment. The line segment is lying completely within the set. So this is a convex set. Right? Suppose I give you the domain as this. Minus infinity to 10. So where am I coming up at? So everything from minus infinity, this entire thing is my number line. Up to 10, 10 not included. Again, I take any 2 points, I join it with a line segment. The line lies completely within the set. This is also a convex set. Now, where does the problem really start? So, for example, if I go ahead and I tell you that x belongs to, say, 1 to 3 union 4 to infinity. Something like this. X belongs to 1 to 3 union 4 to infinity, right? Now what happens is that if I go ahead and if I join it by a line segment, what will I notice? Here I have 1, here I have 2, here I have 3, 4, 5, and so on. So my domain is from 1 to 3 and from 4 to infinity, right? I take any 2 points, join it with the line segment. Is the line lying completely within the set? No. There is some part lying outside the blue shaded area. So this is not a convex set, right? So when we talk about something being a convex set or something not being a convex set in single variable, we look at the domains and we try to understand whether these domains are in a way continuous or not. If these domains are continuous, there is no breakage, we will say that these are convex sets, right? And if there is a breakage, then we will say that it is not a convex set. Now, let us go ahead and let us try to understand what is quasi-concavity and quasi-convexity. Now, when we talk about these two concepts, quasi-concavity and convexity, quasi in a way means partial. जैसे हम microeconomics में we study quasi-linear function, partially linear function. So when we say quasi-concavity or when we say quasi-convexity, quasi-concavity and convexity, these are weaker notions of concavity and convexity. These are weaker notions of concavity and convexity. माने पूरा concave या convex नहीं है. Partially weaker version of concavity or convexity. That is what quasi-concavity or convexity is. But a definition number 1. The first definition says for defining quasi-concavity convexity is that if f of 1 minus lambda times a plus lambda times b, I will explain it in detail, don't worry, is greater than equal to, just write it down with me, f of a, f of b, right? If f of 1 minus lambda a plus lambda b is greater than equal to min of this thing, then it is called as quasi-concave function. Then it is called as quasi-concave function. For example, पहले एक बात समझो. If I take any 2 points on a line, right? I take any 2 points on a line segment, then this entire line segment, जो भी इसके बीच में point lie करेंगे, point C, point D, point E, point F, point G, point H, कोई भी point अगर हम बात करें, any point that will lie between 2 points, it can be written as a weighted average of A and B. It can be written as a weighted average of A and B. Mane, when I say that I want to write 1 minus lambda times A plus lambda times B, I am giving some weightage to A and some weightage to B, then this point is any point between points A and B. C can be written as some weightage to A and some weightage to B. D can be written as some weightage to A and some to B. F can be written as some to A and some to B, and so on and so forth. तो जब भी हम ये लिखते हैं, whenever we write 1 minus lambda A plus lambda B, it means we are talking about points which lie between A and B. दो पॉइंट हैं A और B, उनके बीच में जितने भी पॉइंट्स लाई करेंगे they will be 1 minus lambda A plus lambda B form. Now when I go ahead and when I say f of this, it means that we are trying to find the functional value of those points. हम उन पॉइंट्स की फंक्शनल वैल्यू निकाल रहे हैं. Now what does this mean? It means that suppose I take point A here, point B here, ठीक है, then point A के corresponding में this will be what value? F of A, ठीक है. Suppose this is f of B, this is the value. जब हम B डालते हैं तो फंक्शन का वैल्यू ये आता है. It's not necessary f of A will be less than f of B, ऐसा कुछ necessary नहीं है. I am just assuming कि जब हम A डालते हैं तो ये वैल्यू आ गया. This can be any value, 4, 5, 10, 20, कुछ भी. हमने A डाला फंक्शन में, फंक्शन का वैल्यू आया f of A. हमने B डाला, फंक्शन का वैल्यू आ गया f of B. Now what this is saying is 1 minus lambda A plus lambda B. It means that I am taking any point between A and B. Any point between A and B. And then I am finding its functional value. माने यहां से मैंने कोई भी पॉइंट उठाया और मैंने देखा कि उस पे फंक्शन का क्या वैल्यू है. कोई भी पॉइंट उठाया और देखा कि उस पे फंक्शन का क्या वैल्यू है. कोई भी पॉइंट उठाया और देखा उस पे फंक्शन का क्या वैल्यू है. सो आई एम पिकिंग अप एनी पॉइंट. व्हाट दिस डेफिनेशन इज सेइंग, आई एम पिकिंग अप एनी पॉइंट बिटवीन A and B and I am trying to find out what will be its value. For example, if I tell you that f of x is equal to x square, suppose if I ask you what is the value at 1, so you tell me 1 square 1. I ask you what is the value at 4, you tell me ma'am 4 square 16. Now I can tell you कि बेटा take anything between 1 and 4. 1 और 4 के बीच में कुछ भी ले लो नंबर and tell me what will be its value in the function. That is what we are doing here. We take 2 points, we map their values, and now we take any point between these 2 points. इनके बीच का हम कोई भी एक point लेंगे and we will try to see what will be its value there, right? So now what we have done is, what this definition is saying, कि whatever will be the minimum of f of A and f of B. यहाँ पे minimum क्या है? f of A और f of B में f of A is less than f of B. So the minimum between f of A and f of B is f of A. This is the lesser value. I want that any point, if I choose any point between A and B, it should give me a value which is more than the minimum value. मतलब जब हम यहां से कोई भी पॉइंट उठा लें, A के बाद कोई भी पॉइंट उठाएं, उसका आंसर f of A से ज्यादा आना चाहिए. You pick up any point, उसका आंसर f of A से ज्यादा आना चाहिए. You pick up any point, उसका आंसर f of A से ज्यादा आना चाहिए. It should be more than the minimum of f of A and f of B. Here I have taken in my diagram, I have taken that f of A is less than f of B. Just ऐसे randomly, जरूरी नहीं है. So if I take f of A is less than f of B, the minimum between f of A and f of B will be f of A. So now what I require f of 1 minus lambda A plus lambda B. It should be greater than equal to f of A. माने हम A और B के बीच में कोई भी पॉइंट उठा लें, I pick any point between A and B, उसका जो फंक्शनल वैल्यू होगा वो A के फंक्शनल वैल्यू से ज्यादा होगा. If that happens, then the function is said to be a quasi-concave function. It is said to be a quasi-concave function. ठीक है? Now just write it with me. Quasi-concavity doesn't mean concavity. Quasi-concavity का मतलब concavity नहीं है बेटा. What was a concave function? क्या डेफिनेशन है कॉनकेव फंक्शन की? बहुत सिंपल डेफिनेशन एक कॉनकेव फंक्शन का ये होता है दैट व्हेनेवर यू ड्रॉ अ कॉनकेव फंक्शन, यू जॉइन line then the line should always lie below the graph. तो यहां पे देखो line is lying below the curve ना, so it's a concave function. Similarly, if I draw like this, suppose like this, so I join a line, line is lying below the curve ना, so this is also concave. और convex क्या होता है? Line should lie above the curve, so this is convex. I join it with a line, line is lying above the curve. या फिर this is convex, line is lying above the curve, right? Now what we are saying is that quasi-concavity doesn't mean concavity. Just because something is quasi-concave, कुछ quasi-concave है, उसका मतलब ये नहीं कि वो concave भी है. How I can prove this thing? Just take this. Take this first diagram. Suppose I draw a curve like this. ठीक है? यहां पे मैंने A ले लिया. This is f of A. Here I have taken B. This is f of B. Now just think about it. What is the minimum between f of A and f of B? Clearly f of A. f of A छोटा है, f of B बड़ा है. I pick any point. मैं कोई भी point उठा लूं A और B के बीच का. If I try to find its value, suppose I pick point C. If I try to find its value, then it is greater than f of A. I pick any point D. If I try to find its value, it is greater than f of A. That means you pick any point between A and B. वो point को कैसे represent करते हैं हम? 1 minus lambda A plus lambda B. I pick any point between A and B. जो भी value आएगा, you pick any point between A and B. Whatever values you are getting, this is f of C, this is f of D, जो भी value आएगा, it will be greater than f of A. And f of A is minimum of f of A and f of B. So it means that this represents quasi-concave. This is quasi-concave. ये curve quasi-concave है. But is this concave? Yes, this is also concave. तो ठीक है. This is concave also and quasi-concave also. Now pick up this. ठीक है. I pick up point A. This is f of A. I pick up point B. This is f of B. Now you pick up any point between A and B. Suppose I pick point C. Then you see that that value is above f of A, above the minimum of the two values. So yes, यहाँ पे भी f of C, जो C क्या point है? 1 minus lambda A plus lambda B. It's a weighted average. It is greater than f of A, जो minimum है A और B का. That is true. No issues in that. But this is not concave. This is a line. It is not having a concave curvature. So even a line is quasi-concave. It is quasi-concave in nature. It is following that property. Now let's take the third one. Suppose I draw a curve like this. Right? I take a point A. This is f of A. I take a point B. This can come in exam. ध्यान से समझ लेना in statements को. This is f of A. I take any point between A and B. ठीक है. I try to see its value. Its value is more than minimum of f of A and f of B. So I have picked any point between A and B. वो इस form का होगा. I find its value. And that is greater than the min of f of A, f of B. है ना? वो f of A से बड़ा है. f of A minimum है A और B का और वो उससे बड़ा है. So this is also quasi-concave. This diagram is also quasi-concave. But is this concave? No, this is a convex figure. This is not concave. So it means that something which is concave is coming out to be quasi-concave. Something which is a line, I showed that to be quasi-concave. Something that is convex, I showed that also to be quasi-concave. So I can go ahead and I can say that quasi-concavity doesn't mean concavity. भाई convexity में भी तो quasi-concave हो ही रहा था. So quasi-concavity does not mean that a function is concave for sure. जो function convex थे, those functions which were convex, they also turned out to be quasi-concave. But one thing is common between these three diagrams, and we need to keep that in mind. This was also increasing, this was also increasing, and this was also increasing. तो अभी के लिए हम इसको सिर्फ एक दिमाग में रखेंगे that all three curves or lines that I had drawn, they were actually increasing. We will just keep this in mind for now. अभी कोई use नहीं है, just keep this in mind. So if I give you two statements, a function which is concave is definitely quasi-concave. A function which is quasi-concave is definitely concave. Which statement is true and which statement is false? Or both are true